All right, so good morning or good evening, depending on where you're joining us from, everyone. My name is Jesse, and I am with Exploring by the Seat of Your Pants. If you're joining us for the first time, we're all about bringing conservation, adventure, and science into classrooms around the world. Today's a little mix of all three, which is really, really exciting. So over the last few months, we've been partnering with our team at Reach the World. So Reach the World shares the same mission we do, connecting with classrooms, highlighting the amazing research, science, and exploration happening around the globe in promoting the MOSAiC Expedition. So the MOSAiC Expedition is the largest Arctic expedition in history. It's a ship anchored in the ice, in the Arctic ice sheet, taking data from all manners of scientific disciplines, featuring scientists from all around the globe. It's been such a thrill highlighting some of the incredible scientists that have taken part in the expedition. And today is no different. We are joined all the way across the pond in Germany by Antonia Immerz. So she is a data scientist on board the expedition. She has been on both leg 1 and leg 4 of the trip, going to the top of the world in the Arctic summer and Arctic winter, braving some of the most unbelievable conditions that the Earth has to offer in pursuit of understanding more about our climate and beyond. So I'm thrilled to bring her in with you guys today. I can't wait to get started. If you're on YouTube, let me know where you're joining from. We'll get a whole swath of you guys sharing your questions, and I can't wait. And without further ado, thank you so much for joining us, Antonia. Take us away.
Hi, Jesse, and thanks for that great introduction. And good morning to all of you out there. In my case, it's 3 p.m. in the afternoon, so we've got quite a time shift here. I'll start with my slides instantaneously.
Let's dive in. I can't wait.
Can you see it?
We're perfect. We're good to go. Take us away.
Right. So Jesse already gave a great summary of the MOSAiC Expedition, or as Germans, the MOSAiC word is MOSAiC. So please excuse me if I express it differently sometimes. And it's an acronym and stands for the Multidisciplinary Drifting Observatory for the Study of Arctic Climate. And the goal is to understand the processes in the Arctic and how what happens in the ocean connects to what happens in the ice and above the ice in the atmosphere. And then that information can be fed into climate models. And then with that, we can maybe better predict what will happen in the Arctic and how the Arctic change in climate will affect us globally. And so scientists were out there for over a year and with a ship moored to the floe and collecting all these different kinds of data. So we had ecologists, biogeochemists, atmospheric physicists, of all kinds. They were taking measurements and samples. And all that data, which has been collected, is the real Arctic treasure we're actually taking home. And so maybe I'll start introducing myself. So my name is Antonia Immerz, and I've been working at the Alfred Wegener Institute for the last 10 years. And I've studied computer science because I was interested in very many things, and that gave me like a broad application, and I could have a look at really many different research fields. And but I've always had a passion for the ocean. And here you can see some pictures from my childhood. So I grew up near the sea. And the right upper corner, you can see a picture of myself when I was about 10 years old, seeing my first sea turtle ever. It had about the same size as myself, and I was very, very fascinated. And the other picture is a picture of me and my dad on one of my first snorkeling trips, and I still remember how colorful the coral reefs were and those beautiful little fish. So I was really amazed by that. And that never really left me, that fascination. So I decided to study biology as well. And here you can see me and colleagues on my first trip to the Arctic Ocean. We were deploying nets to collect zooplankton from the Arctic Ocean. And one of these critters was an arrowworm, the chetognats. And they are very fascinating. They appear everywhere in the world ocean. So you find them in polar regions, so at the North Pole and at the South Pole. But you can also find them in warm areas like the equator. You find them on the seafloor, under the ice, in the middle of the ocean. So they're really fascinating. And that's why I decided to perform my bachelor thesis on them. And I told my friends on MOSAiC about that. So friends of mine, they made me a hat for my birthday. And it should look a bit like a chetognat. And they called me Queen of Chetognats. I was very, very proud. And here you can see the gigantic birthday cake my friends baked me for that day. And it's the biggest brownie I've ever seen. Well, so now you know I've already been on the MOSAiC expedition. So I was there on the first leg, we were part of the team that set out into the ice to search for a suitable flow. And when we found it, we anchored to it, and we started setting up the camp, bringing out the cables, bringing out the research infrastructure, and performing measurements. And during the course of the time, it grew darker and darker. So in the beginning, we still saw sun, but then it was only dusk and dawn, and eventually it was pitch black. So the only light we had was from the sun and the stars, and from the stars and the moon and the ship itself, of course. And it also grew colder and colder. So we had temperatures down to minus 30 degrees Celsius, and you can see what happens if you breathe outside there, and the humidity freezes to your face, literally. And yeah, we're out in the Arctic, and there's other creatures out there too. So we had an occasional visit from polar bears, and here you can see beautiful footprints of one of those. And in the back, you can see the moon, actually, that orange dot. So we were exchanged by our fellow scientists and the next crew of Polarstern, middle of December, and then traveled back on a Russian icebreaker to the Norwegian area of Spitsbergen, from where we traveled home. We arrived there shortly after New Year's Eve. And on the way back, we had this wonderful opportunity to see northern lights of the Aurora Borealis on several nights. And it was just amazing seeing those green curtains wavering over the black sky. And as you might know, Polarstern came back because it was so difficult to reach Polarstern in the ice. Scientists and crew, they packed up the camp and set out back to Spitsbergen to collect the next crew and scientists, which were us, in May. So we exchanged at the coast of Spitsbergen and sailed back into the ice. So we had to reset up the camp again. And this is on our first day when we were traveling into the ice. So we had rough sea and the waves were splashing over the deck. It was quite amazing. And when we reached the ice edge, we saw one of my favorite animals, the whales. This is a minke whale, right at the ice edge. And you can imagine how much food there is and how much life that a big creature like a whale can survive in an area like this. Yes, and we finally reached the flow. Here you can see a beautiful picture of it. The ship is on the edge of this circular area. That's the main flow, and around it you can see smaller circles. That's the flows around it. And the situation was quite changed, so we didn't have polar night anymore. It was polar day, which means that there was bright daylight throughout the 24 hours. So even in the middle of the night, you could go out and see the sun. And by that, also the melt season had started. So here you can see all these blue spots on the flow. That's actually water, so melt ponds on the flow gradually melting. And this is one of the melt ponds from the proximity. So this blue area is not the open ocean. It's actually a huge, gigantic melt pond. And in the back, you can see Polarstern, the icebreaker. Yeah, and these melt ponds, they drained to the open ocean. And here's one of these drainage channels. You can see that there was we were wearing survival suits so that if we came into some hazardous areas, if we ever did fall into the water, we would be safe by being dry and warm, and we wouldn't sink. So that was very good. And it was very exciting to see all these different phenomena happening. So through the melting and refreezing, we had all these different types of ice, and I know nothing about it actually. That's for the scientists, but it was just beautiful patterns and colors which you could observe throughout the flow. Here's a picture of a melt pond. It's just one connected melt pond, but you have very many different shades of blue. Yeah, and I said we had bright daylight throughout the 24 hours, but that doesn't mean that we had great visibility all along. So there was many days with fog also, and that made visibility quite bad sometimes. So it made working out on the ice also very challenging if we couldn't see beyond 100 meters, let's say, or even less than that, because our friends, the polar bears, were around also frequently. And this is a beautiful picture of a mother polar bear with her polar bear cub. It's the smallest one I've ever seen. It was very cute. Well, so what were we actually doing out there? We We wanted to measure all these different parameters, what's going on in the ocean and the atmosphere and on the ice. So we needed to set up lots of research infrastructure. But lots of these instruments, they need power to run. And you might need sites where you need light, or you might want to control some instruments from the ship, which means you need a network connection, a data network. Now, don't get excited. We didn't have YouTube or Facebook or something. We weren't connected to the internet, but we did have an internal network on the floe. So we could communicate from the ice to Polarstern and different sites. And here you can see my colleagues bringing out some cables. So how do you get power and data network out on the ice? You use cables, and they were all over the floe. And they were connecting the ship to power hubs out on the ice. They were quite big and heavy, up to 700 kilograms, I think. And from there, the power and the network got redistributed among the cities, scientific sites. And you can also see that the ice is attaching to the cables already, so it was really cold. Yeah, and here's a picture on the right of one of these power cables, the orange one. So they're really, really big. You don't have something like this in your household normally, so that's really strong power for big, big instruments. And the black cable on the left, that's the fiber optics cable for the data network. And the picture on the left, you can see how these cables were then transferred up onto the boat, onto the ship, to be connected to the power source on the ship. Yeah, I already told you that we had to do this twice, because we had to set it up on the first leg, but we had to reset it up all on leg 4 again. But this time the situation was a bit changed. So we had the expectation of the ice being growing thinner, so we couldn't bring out all this heavy stuff. The power hubs were far too heavy, and so we didn't take the poles, for instance. We just put the cable out onto the ice, and lots of this, as on leg 1 as well, was done by hand. So we wanted to minimize the footprint we make by using skidoos or something, and also some of the areas on the floe were not really well reachable by means of skidoo. Yeah, so also the power hubs, I told you, were a bit smaller. So now the power hub is actually this metal box on the left-hand side, and the power gets redistributed from there. And then here we have an example of a wireless data connection. So this is a radio link antenna, which transmits data to and from the ship. And the data cables then come into the gray plastic box, which you see in front of the two men. Yeah, and these two friends of mine, they felt very brave and adventurous, and as if the source were with them, the force were with them. So that was a great sunny day. Well, now having the power out on the ice and a data network established, which was all done in a team effort, so everyone really helped set up all that infrastructure. And the scientific instruments could now be set up. So this is scientists putting up an atmospheric measuring pole with different measurements being performed on it, so they could measure wind speeds, air temperatures, and other things, everything that happens in the air. Other scientists, again, were interested in what happens in the ice. So they took ice cores, having a whole, seeing all the layers of the ice floe, and this was then dissected into very small pieces and then analyzed in the lab, so they could find out how much salt was in those ice cores, how much plankton, which kind of gases they would find, all different kind of stuff. Yeah, and to give you some more examples, this is the ocean team. They're digging a hole through the ice because what they're actually interested in, it takes place below the ice. So they want to measure water temperatures and currents, everything that happens beneath the ice. And some of our colleagues, they went even higher up. So here you can see 2 tethered balloons, this Piggy and the Tropos balloon, and they can go up to 1.5 kilometers, I think, up in the air, and they are connected via lightweight fiber optics cable, and all the instruments attached to the balloon, they can also measure humidity, temperature, and so on, gets then transmitted down to the data logger at the bottom of the balloon. And if you want to measure things that are even higher up, you have to use radiosondes. So this is a balloon which was launched every day. I said several times. I got to launch one as well on my birthday. I was very happy. And they go up to 35 kilometers in height, and they measured temperature, humidity, pressure, and other interesting things. Yeah, and these are the last two examples. So other colleagues were also measuring radiation, so how sunlight gets reflected from the flow. So there's different types of reflection, if it gets reflected from water or ice or snow, and that also affects all the processes in the Arctic. And this is actually my favorite task. That was the transect. Several times a week, one would circle around the flow and taking ice and snow thickness measurements. And with that, one could observe how the flow evolves over time, how melt ponds grow and shrink again. And it was a great opportunity just to see how the flow evolves, and also to take a walk. Yeah, and some places that measurements were made were so remote, or on other parts of the flow that had broken off, or even on another flow that you had to get there by crossing the water. So you either had to fly, which was quite costly, and if it was foggy, not always feasible. And the other option was to go by kayak. Well, so now I gave you quite a few examples of what is all being measured and sampled on the ice and under the ice and on top of the ice. And you can imagine, here's a picture of a group of scientists, and they're all doing something different. So this is quite a lot of different information that is being collected. But what our real aim is to interlink all this information, to relate it with each other. And normally one would maybe put the data on your laptop, take it home and analyze it. But in MOSAiC, we wanted to go beyond that and compare the data with each other and see what the global picture is of it. And for that, we need some kind of central place where the data is uploaded. And that was the MOSAiC central storage on board Polarstern, where all the scientists could upload their data on board and then already access it, so their own, but also that of the others. Now, you can imagine if you have a wardrobe and you put in all your clothes in there, and your friends also, and the friends of your friends, and nobody organizes it, you'll have quite a big mess after some time. So we needed to find some kind of structure that everyone could adhere to, so that one could find their own data, but also that of the others. And additionally, this data was secured, so in case something broke, we still had a separate copy. Now, it's not only important to have like a central place where everyone can access the data. To work with the data, you also have to understand it. And this is a wonderful picture drawn by Amy McFarlane. She was on leg 4 with me, and she really visualized it really neatly, what was happening. So you see all these different people in different parts of the flow, some in the water, some on the ice, some in the air, and they're taking measurements and samples everywhere at the same time, or maybe after each other in the same place, and they're all collecting data. So, but to make it comparable, we have to know where it was taken. So were we measuring the melt pond on the east side of the flow or the right side of the flow? At what time was it? Even more, you have to be more specific. So you can't just write down the time. You have to say in which time zone we're actually measuring the time, because it makes a big difference. As you know, we're 6 hours apart, Jesse and me at least at the moment. And even what's also important is to say what you are measuring, so with which instrument, but in which unit. So you can't just say I measured 5 temperature. We really want to know, was it 5 degrees Celsius or 5 degrees Kelvin? It really affects the general result. And if someone wants to work with your data, maybe even in years to come, which is the actual goal, to have all this data available to the world so everyone can use it in the end and draw results from it, then we really have to make sure that also generations to come can still understand what we've been measuring. And we had systems to register this information, this additional information. We call it metadata, for when the sample was taken, with which instrument, and at what time, and together with structure, how the data should be uploaded. And with all these different disciplines, you can imagine that we are having quite some discussions to find like a compromise that everyone would be happy with, and that were rounds and rounds of meetings. And this is a picture of a bunch of us very, very tired after some hours of talking and discussing how to do it so everyone could find his way to upload the data. And in the end, I think we found a good solution. But the scientists were never alone. So we were there were always data supporters on board Polarstern, and they would help scientists how to upload the data, how to register their meta information. And here's a picture of the data supporters of leg 4 and leg 3 during the handover. Yeah, we were always happy to help. Now we have all this data on the central storage on board Polarstern, but we really want to take it home, right? We wanted to have it on land so that our colleagues on land could already work with the data, and later we want the world to access it. So we needed to get the data somehow back home. Now, transmitting the data via satellite was not really an option. It would have been far too costly, and it would have been far too slow. So, and we couldn't take the storage every time. It wouldn't have been on board, and it's far too big. You can't pack it in your suitcase. So what did we do? Well, we used these magnetic tapes. So there's these small box-shaped things, and 5 terabytes fit on it, so that's quite a lot. And after each leg, the data supporters took a bunch of them in their suitcase and brought it back home to the Alfred Wegener Institute in Bremerhaven, where it was uploaded, the data, onto a big central storage from where the data is accessible from the whole MOSAiC consortium at the moment. And since it's been described well, with time and place and instruments, and also in its well-defined structure, people from the whole MOSAiC consortium now can access it from all over the world and work with it. And they'll be scientists will be analyzing it and comparing it and interrelating it. And but that's not enough, right? This is so valuable data, and there's so much information to derive from this, that generations to come could actually work on this data. And that's really important, because when new methods are available, new techniques to work with this data, we might gain whole new insights into this. So on the 1st of January 2023, all this data will become publicly available via so-called data repositories all over the world. And then everyone is invited to look at the data and work with it and drive their own results from it. And who knows, maybe you, in a couple of years' time or some years' time, will be writing your bachelor thesis on one of the data sets that we obtained during the MOSAiC expedition. Yeah, and with that, we hope to understand the Arctic climate better and how it will affect us globally. Okay.
How cool is that? Well, thank you so much. Every time we get the chance to hear about MOSAiC, it blows my mind every time anew. It's such a cool expedition. There's so many amazing people and stories, and really appreciate you sharing all that with us today, including the giant brownie, which was new for us. We had not had a giant brownie yet in the history of our MOSAiC talk. So I appreciate that, Antonia. So let's dive in with questions. If you're on YouTube and you want to share questions in the chat bar, please do let me know where you're joining from. I'd love to take your questions. Miss Smith, I'm going to come to you live in just a minute. Let your class percolate with all that for a minute and cover some questions. But I want to start off with a one that we've gotten for every MOSAiC scientist so far, which is, how did COVID affect your expedition? So the second leg, I know that the ship needed to come out and come get you guys. Was there any other way in which traveling to the expedition or the scientists that could come was adversely or positively, who knows, affected by what happened over the last few months?
Well, it was a great challenge, and I think especially people from the leg 4 where I was on, we really appreciated the possibility to actually be close together and be able to touch each other in the end, while the rest of the world was in a very difficult situation. So even though we were quite far out, life for us was maybe a bit more normal than for most of us at home. And you learn to value those things which you hadn't thought about before. Yeah. That's definitely true. And but we had to prepare quite a lot. So before we could travel, the entire crew of Polarstern and the transfer vessels and all the scientists, we had to go into quarantine for I think it was about 2 weeks, and we were for 6 days. We were even in self-isolation. So we were in hotels, and the hotel staff. They brought us the food in front of our door, and they knocked the door, and then we were able to take the food and eat it on our own. And then after a week and 2 COVID tests, we could then regroup with keeping the safe distance, of course, and not leaving the hotel, or at least not the area of the hotel. And then we got transferred to Spitsbergen. So it was, it did affect us quite a lot, and it did change a lot of mindsets.
Yeah, thanks, Antonia. So when you're growing up, you're becoming a data scientist. Did you ever picture anything in your mind that was remotely like this? Like, did you picture that something like this would end up being part of your career, or was this like the goal? Like when you were younger, you're like, okay, I'm doing this so I can end up on super cool expeditions in the middle of amazing places. How did that all pan out?
Well, I always was fascinated about the Antarctic, actually. The Arctic came to my mind later, and but nevertheless, it's really exciting. What I was actually aiming at when starting computer science, I thought I might be able to program games that are concerned with nature conservation, for instance. And what would have been a dream is I heard of 2 computer scientists working with whale biologists and measuring the acoustics of whales. And I thought, well, if I become a computer scientist, I might be able to do that too. So, yeah. So it's close. It's something different, but it's as exciting, I would say.
Just really quickly before I go to Ms. Smith, have you ever had the chance to go to Antarctica yet? Or is that like bucket list, next stop, now that you've done this, you're totally on every top of everyone's list for next expedition?
Bucket lists, definitely.
Bucket list. Yeah. Okay, well, once you've been, we'll follow up. We'll do a follow-up presentation and catch your take on that. We've had a lot of people on this broadcast that have been to both, and it's just always such a special experience to go to the remote corners of our planet. So very cool. Ms. Smith's right down the street from me here in Toronto. So Ms. Smith, come on in.
Hi. So thank you so much for that very informative presentation. My kids were wondering, how did you guys select your team? So we have 2 questions. How did you select your team?
So the team of science, so the crew, it's organized by the shipping company, and they have 2 shifts in, generally speaking, and it's quite clear who goes when, apart from some individual shifts. For the scientists, they are organized in different teams. So we had team coordinators for each team. So there was like a head of the eco team, a head of the ocean team, and so on. And within those teams, there were very many different scientific groups, maybe even across different institutes, who were considered with one research field of the expedition. And that all got organized within the scientific teams. So they decided which kind of science will be done on which leg, and who's an expert on that field, so who would be good to go. But then, of course, people need to have the time to go. They have to be able to leave their families, or it has to fit with the work schedule as well. And for the data team, most of us that were hired from a different company, and they did the data support. And it was just myself from the AWI who went there because I was aware of all the data management in the preparation phase before.
Yeah. So a mix of sort of world-class expertise and ability to get there and ability to leave for that period of time. Like there's a lot of elements to this. So thank you, Ms. Smith. And we will come back for your second question in just a minute. A great quick follow-up from Madison in Wisconsin from Ms. Becker, which is members of the team from Germany or from all over the world. So you explained that they're from all over the world, but where from? Like the people that you worked with specifically, were they from anywhere specific that you can tell us today?
Wow, they were from really very, very many different countries. So I had Italian colleagues, some from Greece, lots of Americans from the UK, Russians, and they were not only from one institute, from several different institutes. So I think one of the last numbers were from over 20 different nations and over 60 different institutes. But it was very international.
Awesome. It's one of those nice things. It's like Antarctica, actually. It's sort of an international research celebration. International Space Station is another great example where people come together from all over the world, whatever their backgrounds may be, and it's just a fantastic opportunity to work together in pursuit of knowledge. So very, very cool. Thanks, Antonia. All right. I'm going to come back to Ms. Smith in 2 seconds. So going twice, you went on the second time for leg 4. Did it feel different? Did it feel really familiar? Where you're like, oh, this is back, home sweet home again? How did that all feel?
Well, some of these things were home sweet home. I mean, the first time everything is really exciting. You do it for the first time and you don't really know what to expect. I'd been to the Arctic before once, but not really on a drifting floe, working out on the ice. So that was like really exciting. And then all this new data structure to work with, and all these problems which were coming the first time, and these challenges. So that was quite exciting. But in total, it was very, very different. So the first time it was pitch black, and we had the sun not going up, getting up in the morning. The second time it was bright daylight. The ice was totally different. So on leg 1, we had lots of movement in the ice. So there were these cracks and these ridges being built. And on leg 4, we did also have some movement, but it was far calmer. But then the ice was changing so dramatically all the time. So it was every time it was mind blowing, I think you say in English.
Yeah. Good phrases, any. By the way, you definitely did it in the right order. It's good to start with perpetual darkness and then go to light. I think anyone who started in the light was like, no, I don't know, I want to go to the dark after that. Very, very cool. All right, Miss Smith, come on back in. Go for it.
Yeah, so we also, I think the presenter mentioned computer science, but a lot of the students were wondering what other areas of study would you say that your scientists may have majored in universities, and also how long it might have taken?
Yeah.
So you mean for the scientists which performed the measurements and went out in the field and investigated ocean and air and so on?
Yeah, so what sort of disciplines were they in when they were in school? And then how long are you in school to end up in a position like yours?
Well, I guess that really depends. So all went to university, I suppose, most of them, apart from the technicians, for instance. So if you want to become a scientist, I think in the most cases you will have to study at a university. But if you just want to work in science, you can also become a technician and support scientists. So you won't be doing the actual research and writing the papers, but you will still be maybe deploying nets or taking samples and working with the samples. So to become a scientist, there's lots of different fields. So we had oceanographers, physicists, biologists, chemists, biogeochemists, and I don't know how it is in the whole world, but in Germany we have, so we had the old system where we studied about 4 to 5 years. Now it's like a bachelor's degrees, which goes for 3 years, and a master's degree where you specialize a bit, which goes another 2 years. And then you have to write a PhD thesis, which takes another at least 3 years, but lots of people take a bit longer because that area of research is a bit bigger. And then after that, you become a postdoc and you start doing your own science career. And so we had lots of, on leg 1, we had lots of senior scientists. They already had a postdoc and they had been working in science for quite some years, maybe more than 10, I guess, most of them, maybe more than 15 or 20. And they had their own research groups already. And during leg 4, we had a lot of young researchers. So some of them were still working on their PhD. Some had just finished their PhD. And we even had one who had was just finishing with his master's thesis. He was actually also on leg 1. So that was quite some mixture.
So because I've had students before where I like that sort of the idea of that much extra schooling is very daunting. So we have a grade 6 students in Mrs. Smith's class. And so, yes, for students that are looking at a job like Antonia's, you're looking at 12 plus years extra of school from where you are right now, which seems wild and crazy. But what it means is that you're in your mid-20s and now you're equipped to do high skills careers, have really fulfilling and exciting roles throughout your entire life. And really, by the time you're in your mid-20s, you don't feel that old. I promise you in grade 6, you're not that old. And there's so many exciting opportunities out there from that point. So keep that in mind. Everyone, a lot of the people that we have on this broadcast do that work. They end up with a master's degree or end up with a PhD, and pretty much universally, I'd say they think it's one of the best things they've ever done. So just keep that in mind there in grade 6. All right, Ms. Becker's class, what kind of food did you bring? What are you eating when you're on the ship?
So we were well fed all the time. We had at least 3 meals a day. There was breakfast, lunch, and dinner, and we had coffee time where we got cake. We had wonderful cakes. We had a great baker on board. And there was also food in the fridge we could also always access. Yeah, I mean, during the scope of the expedition, fresh food got a bit diminished, so we were more down to noodles and rice, and everyone, or not everyone, but many people brought their favorite food, like the favorite chocolate, which they always like to eat. So but we had chocolate on board. We had a store where we could buy some things, but maybe not like the special treats that one would have. But we had tea and coffee and different kinds of drinks, and yeah, it was.
If nothing else from this presentation, just you wistfully looking into the middle distance and going, plenty of so many good cakes is just a glorious moment. So thank you for that very much. I'm glad they were well equipped. Dangers of being there. This is something that we've covered on pretty much every MOSAiC Expedition talk. So when you're there, what are you worried about? Now, you showed the cool polar bear footprint, so I'm guessing polar bears is part of that. But if you could explain what else is sort of the risks and challenges of being on board the ship, that would be fantastic.
Well, the polar bears are one risk, of course, and you really try to avoid meeting them, which is why we always had polar bear guards, or we're watching out for polar bears all the time as well. So one person was doing that for each team at least. And but there were much more prominent risks, like being out in the cold for such a long time, not getting frostbite. You always need to make sure that you brought a warm hat, that you maybe brought a second layer in case you got wet. An extra pair of socks was something everyone had in their suitcase and their rucksack, and in case one got wet feet. They had to be exchanged, otherwise you get cold very quickly. What else? I mean, losing orientation in the dark was also something which I was experiencing. So everything is completely different. You have nowhere to navigate. So normally I would have a look at a tree or a house, and then I know at next corner I'll turn left. But that's quite different on a floe middle in the Arctic Ocean. You have to, restructure your thinking, and not losing time, making sure that the group always stays together, that you don't lose someone. Those were much more prominent risks that we had to deal with in daily life.
And I love that your pictures illustrate that, being in sort of a featureless landscape in the dark, trying to find your way where it's biting cold, there can be heavy duty winds. I mean, this is really an extreme environment, and one that, again, some really, really cool science is being done at, and I'm really excited to be able to share these stories. So thank you again. All right, we'll take a couple more questions before wrapping up. Ms. Smith, if you want to share one more with us, come on in.
Yeah, so my student Azan wants to know if there's anything unusual that you found so far.
Ooh. What's the most unusual?
I'm sure that the scientists found lots of interesting things, and they're working on it to find out what else interesting has happened there, and they'll be talking about it very soon. Something that I found really, really interesting is that we found stones and shells and sea stars and algae in the floe. So it was frozen into the ice, and it was really exciting. So we went onto the ice floe, like onto a beach, and we were collecting stones and seashells. So that was really, really exciting.
Yeah, that is really exciting, and I don't even know sorry, like stones, it's funny, we've covered Antarctica before, where stones quite often are like meteorites that have come in and landed. That's how you know that they're meteorites, is because there's no stone for them to have come from. But like a sea star, like where does that, I mean, they live on the bottom of the ocean, but like how do they get in the ice? What's going on?
So the scientists assume that they got frozen into the ice in the area where the floe was actually formed near the Siberian ice shelf. So then there it was near to the bottom, and that's when all this benthic stuff got frozen into the floe. But yeah, I'm not sure if they're 100% sure about it.
Okay, well, very cool. I mean, it's one theory. It could be like just dropping from the sky too. We've got flying starfish. We got all that. That is fascinating. That you're the first person to mention that, so thank you for that. Before we wrap up, I'm going to last one more. Again, time flies when we're having fun, Antonia. I told you these would whip by. I want to share a couple more things for our students at home and on YouTube. So number one, the MOSAiC Expedition. If you want to learn more about all the amazing work being done, check out the link that I just put below me. Again, incredible stuff, tons of scientists, and a lot of our past YouTube sessions are on our YouTube channel as well, so check those out. And then Reach the World is our big partner for this. Reach the World has done such an amazing job in highlighting the MOSAiC Expedition, so I really encourage you to check them out, especially Arctic Treasure, which is Antonia's piece all about her efforts there too. So if you want to follow up with today's talk, check out the link below. Some really, really cool stuff. Antonia, before we wrap up, is there one last message you want kids to take from this? If you're at home and you're watching this and you're learning about MOSAiC and you're learning about all the cool work you're doing, is there anything you'd, I don't know, highlight to them, recommend to them, anything to cap us off today?
Well, if it's some advice or something which I can say from my experience is just to follow your dreams, and even if you might not get them directly, you might get somewhere close, and definitely you're going to experience lots of interesting stuff and fascinating things. So it's always good just to go forward and see what the world brings to you and try and protect it, and be sensible with the resources that we have here.
Yeah. So many of the people we come on share that, which is so exciting. And I mean, whether you are in grade 6, whether you're in grade 12, or you're in kindergarten, you know, follow those things that you're passionate about. Go volunteer, take part in those things. If you love animals, go to a zoo, actually interact with animals, read lots. I mean, these things are universals from all the scientists and explorers we bring on. Always a nice opportunity to get inspired by what the world's like out there. And then hopefully you end up in a really cool job like Antonia's down the road. So thank you so much for sharing your time with us today. I appreciate it so much. And what we do at the end of every broadcast, I'm going to bring in Miss Smith. Miss Smith, if you want to join me in saying a big thank you and goodbye on behalf of your class, I'll end the broadcast there.